some background for myself. I joined Microsoft in 1999. Previous to that, I worked in digital, where we monitored systems in the field, and I sort of worked with the Windows group prior to joining Microsoft, and worked closely with them during the release of, well, I still work with them, but especially during XP 2000 and some of the subsequent releases. So what I'm going to talk about is really some background. Instead of just saying, you know, this is Windows XP, you have to understand where it came from. And of course, you have two major development routes in operating systems in Microsoft. There's the sort of Windows classic operating systems, and then there's NT. So I'm going to go through the history of those, look at some of the development of XP in itself, look at the features that XP introduced, and then the supporting of XP, because that was actually quite a major undertaking. You have to discuss the security issues when you're actually dealing with XP and looking back and how they occurred and what's happened since then, and then just sort of a personal perspective of XP. So where do we start? Windows 1 wasn't a big seller. 1995, first movement into here, bundled with Paint, Write, Windows Write, which disappeared without trace, Notepad, which is still around. Second iteration was 1987. Excel and Word first appeared. Obviously, Excel and Word was also, all the graphic stuff was also being done at the same time for Apple. And it had 1 meg of memory allowed. And then Windows 3, and now you're getting to sort of a bit more commercial. 10 million copies, multitasking, had a video card. So it actually worked slightly faster than before. And then as this was developing, there was 3.1. A 3.1, you were getting into a credible product, going into TrueType. You had work groups. It started thinking about networking. So instead of a standalone entity, again, you had the bug fixes coming in. And then you had 95, because 95 was the big major seller. It was the one where really, at that time, it was where Windows took over from Apple, simply because you had all of these people, which you've seen most of them here before you, making computers at very low cost. You had, it was 32-bit, but the kernel was 16-bit, so this sort of backward compatibility was already an issue that we actually had. It ran in 386 enhanced mode, and it could actually handle 2 gigabytes of memory. Obviously, if anyone remembers back in that time, the idea of 2 gigabytes of memory is, I bought, when I was in digital, 1 gigabyte of memory in, I think it was 97 for £100,000, and it was a rack. So 98, now you're getting into something which is both, 95 was sold to the home market, big seller. From gaming, you know, the home market is the fun market in the sense of how people want to use it. And you're now coming into Windows 98. We started with the FAT operating system, USB support, started being taken up by industry as well. And then we had Windows ME, and we'll just forget that one. Windows ME, because actually there was a reason. I mean, I know it seems strange, but there was a reason why it was produced. So we go to NT. Now, most people's view of NT is simplistically. NT, Microsoft worked with IBM and on OS2, and there was, you know, to say the least, it wasn't exactly a happy divorce. And people believe that NT is simply a continuation of OS2, and it isn't. NT started with Dave Cutler. Dave Cutler went to university on an American football scholarship. Basically, he started with the RxX. He then was the main architect of the VAX and then basically VAX VMS. So basically, you have one person who is responsible since 1980 for all the most popular non-Unix-based operating system, consistently for 30 years. He was hired to continue OS2. If you know Dave Cutler, the concept of him actually following anyone's instructions is zero. So basically he did Windows NT. Windows NT stands for Windows New Technology. There is no coincidence that this is one letter greater than VMS. Microsoft was sued by Digital because the Prism, which is the thing that forced, well, Dave Cutler gave up on them when they cancelled that. Somebody noticed the similarity between NT and Alpha, and they pointed out, well, it's the same architect. So they sued, and Digital won, so there is a resemblance between VMS and Windows NT. So they brought out 3.1. So the first release was 3.1, and this is a marketing wanted synergy between, so instead of NT1 and Windows 3.1, they wanted this synergy. That was the naming convention that was used. And it started, into advanced connectivity. It had NTFS. It was, again, very much written from an OS perspective. And in those days, OSs assumed that the people writing drivers actually knew what they were doing, which we'll come into a bit later on. 3.5 and 3.51, you were now getting into something which actually was starting to go into companies. When I was in DEC, Compaq were then making Compaq Proline servers. We bought them, we did a teardown. So the current servers at DEC were about same sort of size, were about, say, 30, 40,000. These things were coming in about 10,000 a pop. The big difference between them is that they had hot swappable power and fans. When we did a teardown of their CPU, compared to the DEC CPU, VAC CPU, there was no comparison. So much better engineering within the DEC CPU. The big issue is the major failing part of a product was the power supply and the fans. And to fix our power supplies and fans, you needed a service contract, and you needed to take the CPU out. So they made it very simple. Plus, you couldn't put two major server products on the product at the same time. It was just the memory leaks would kill each other. So these were being run as a single app servers, which was a joke at the time because really, VMS could handle any number of applications running in parallel. But from a system management perspective, this was a dream come true. You didn't have versioning, you didn't have conflicts between applications, you didn't have driver issues, library issues. So managing it, and so basically their view was, we can buy two of these, we've still got half the price of your VAX machines. And with two of them, they're roughly the same reliability. And it's, you couldn't argue against it. You could see the way things were going. You then had NT4, and NT4 was now getting into a lot of enterprises. So a lot of companies had invested a lot of money with NT4. But you had this thing, we're developing two operating systems. So how can we merge the two operating systems into one operating system? It makes sense because operating system is an operating system. There's no big difference between them. They brought out the Workstation Server Edition. So basically the idea is customers would have the client and the server within the same business. Getting heavily into administration tools to manage it. And we supported Alpha. That was because of the legal thing between us and Microsoft, and us and Digital, MIPS and PowerPCs. And then bringing in DirectX. So you've got this weird thing of why you've got a server operating system with DirectX, which is a gaming thing. And the obvious thing to do, which is prior to the release of NT4, was NT5. So NT5 was basically, let's just have one operating system. A home and a server operating system make our life so much easier. Because what was happening was that people were saying, well, I've bought this product. I want to run it on both my home machine or my Windows 98 and my NT4, which of course then puts if you've got two products, it puts great cost on the application writers. Unfortunately, it's incredibly difficult to do. There's a great book called Microsoft Secrets, and it was written about 95. And it's all about the issues that Microsoft had at that time. And the authors had this great phrase of PC hacking methods. And actually, if you look at what the methods were, they're now called agile. And it was a lot to do with the idea that you release the product when it's ready, engineering-driven culture. And it was hitting limitations. It was hitting scaling limitations. Also, even though it's exactly the same piece of code near enough, the customer requirements are completely different between the home market and the server market. So one side wants high reliability and availability. Home users want fun. So basically, as if something, a new product or adapter was released a month ago, you want that incorporated into your PC. Well, the server market, that's the last thing they want. They want a year between one and the other. So things started going very badly. And basically, they had to replan around about 98. They decided it was just simply unachievable, simply because of the customer requirements in both sides. And this is where Windows ME came in. They had to do two things. One was Windows 98 SE. One of the big reasons for that was that this, if you were around at the time, was this obsession with Y2K compliant, because the world was going to come to an end because we used 2 digits to capture the year. And so people had to then, the US government virtually forced Microsoft to come out with something which was Y2K compliant. And Microsoft was saying, what do you mean? Please, okay, we'll give you 4 characters. Whoa, there you go. And then they brought out MA because they knew that nothing was going to come out before at least 2001. And it really taught the factors that trying to rush something out in a year was a disaster. And actually, we finally achieved simultaneous releases in Windows 7, which was done in 2009. So they actually, the rumor was Bill Gates named it Windows 2000 to force them to release it in 2000. So it was like you cannot possibly slip this. They did 4 editions. So the idea is that the business users would use Win2K Professional, and then the home users would use the 9X. Again, a lot of server activity, Active Directories, improved DNS Manager. They were already merging the 95 features with the 98. Now remember, there's 2 different groups. And if you have 2 different groups of software engineering, there's an awful lot of jealousy between the 2 groups. Software engineers do not work happily together in 2 different groups. It's just, so they then got into the Windows 2000 development. So basically, when they released Windows 2000 in late 99, which is released to manufacturing, they unified the code base. So the way it was working in the past was each major groups would have parallel branches, and they all worked perfectly, and then basically when you combine them all together, it didn't work. So they moved into a unified code base, increased focus on tools, processes to manage the code through to the system. They, in a sense, slowly migrated from the engineering perspective. So the engineers submitted code, then the build process would actually run it through the branching system into what was the main branch. So there was sort of like and that would go through quality gates to ensure that the system, it worked at a system level. And there was a big thing about breaking the build. If you broke the build in the main branch, then that was a sort of career-limiting activity. At the start, they were building it nightly by 8 o'clock. Microsoft has always done nightly builds, and if you know your history, then you know that the Apollo space mission also did nightly builds, so it's not exactly a new thing. When they started, they were actually deploying on the night to 1,000 machines. We're now, by 2001, we're now deploying to 4,000 machines. To give you some perspective, is that the number of machines we deploy to now is limited by, we're working in about 2 buildings at the moment, and our limitations is the legal amount you can put power into a building. So there's a limitation on how much power you can apply to any one building, and that's our limitation to the number of machines we actually have. Plug and play was massive. Massive sort of reason for it. 98 compatibility list was far too big. We cut it back to what we could do. There was thousands of devices. There was this wonderful thing is this people would actually just have unlimited money to go out and buy a new device, any new device they saw. They were actually, when I joined, there's this surreal thing where they were basically saying, go and buy games and play them in your own house, running the latest operating system, and see if it works. So I've come from like DEC, which is like by that time it was taken over by Compaq, so it became a sort of manic control freakery company. And so here was this other company saying, just go and play games. Like, whoa, weird. But the code base for Windows XP was on the same branch line. So Windows Server 2000 used the same sort of kernel. So basically, not only did they have to ensure that the Windows XP ran on tiny laptops, you had to still work on servers. So it was running it on 32 Pro processor servers to ensure the kernel, there wasn't a mismatch onto the whole, on the two operating systems. The driver model was interesting. So again, a guy called Rob Short said that our driver model was excellent as long as people writing the drivers knew how to write kernels. So it assumed this level of ability, and there's just too many drivers in the kernel. You're talking, so I mean, you've got 10,000 kernel drivers, plus multiple versions per driver. And because this is a massively popular operating system, and by this time Windows is sort of the dominant operating system. So basically anyone who's writing any driver had to write it on Windows. And so these were sort of cheap devices drivers were written by people in garages all around the world. And naturally enough, the quality was dreadful. So if you looked at this from a classic software perspective, then this was a dreadful thing for us to do, a dreadful architectural decision. Except speed. If you abstract sound and abstract video in the late 90s, then your machine was too slow because they had the 9X series of machines which had no abstraction and they were fast. So there was no way you could bring out and say, come to this new operating system, it's got all these wonderful facilities, but it's slower. So all your games isn't going to work, or it's going to be really slow. That's an advertising thing that didn't work. So from an architectural perspective, this was a mistake. From a business perspective, and actually from the fact is that once Windows XP came out, that killed the Windows 9X thing. Although in fairness, probably people thought that if ME was the last release, then they didn't want ME2 or whatever. So the customers. And this is, when you're writing, even if you look at the agile methods, all methods is basically you have to write to your customers. And you run into these issues. The 9X customers were the target customers, which were the home customers. They weren't. You had corporate customers in their thousands, they had tens of thousands of 9X machines, which were clients to servers. And so basically, you're now talking about tools to manage those machines, which is what they're interested in. Whereas the home users obviously couldn't care less about tools to manage machines. So you have two completely different things. Now, when you've got a large software development, and you can manage it multiple ways, but the most effective way is to manage it based on a time. So you're going to release in a certain time. And if you're going to release in a certain time, the only way you can release in a certain time is manage it through features. So in the sense is you basically say, we're at this point here, which features do we cut? And as soon as you start talking about which features do you cut, you have to figure out who your customers are to say how to prioritize those features. And that was very difficult. And it's this prioritization. And so some of the cut features is a mixture of the two, the remote boot and the real-time scheduling, which again reflects the facts is the schizophrenia regarding which of our customers there were. The remote boot was actually quite funny because when they were deciding that they had to reset and they had to cut some features, all the engineering managers got together and those were the ones they decided to cut. Simultaneously, Bill Gates went round to all the big customers and said, what features do you want? And that was the biggest feature. And so they all met up and they presented to Bill this list. And of course, Bill had sort of slight temper. So his phrase was, "Which effing genius decided to kill this remote boot?" And there was silence in the room, and then someone turned around and said, "Hey, Rob, Bill thinks you're a genius." And for a year later, this person was called the genius. Unfortunately, that was before Apple demoted the phrase genius, which is now the 16-year-old kid with pimples. So, before they released Windows, it was now this has been done in 3 or 4 different companies, but this is the first time it's done on sort of like a client, is the crash dump collection. This is quite a normal thing now, but only DEC, IBM, HP collected crashes at this point. So basically they decided to collect crashes. So you suddenly come into, well, we can't collect the dump file, we have to collect a mini dump. So what data can go into a mini dump such that you can make sense of it? How do you get permissions to collect data? How do you transport it? When do you transport it? You don't want to transport it as the system is rebooting because kill the system. Privacy. One of the good things, and this is the good thing about Microsoft, even in 2000, was the idea of really, so if we collect dump files from customers, we really don't want to know who the customer was, because that just leads into all sorts of privacy issues. And then if you want to not know who the customer is, then how the hell do you give them feedback? It's things. So the way they do it is this basic process hasn't really changed all that much. You strip the PPI data as soon as it arrives in, so nobody in Microsoft can actually see this data. Crash dumps are analyzed by a thing called Bang Analyze. And we keep the socket open, so we basically can send the results straight back, and then we store the crash data for future processing. And this process has developed much more in the future, but this was the fundamental architecture that we used at that time. And so the day of the release, this is actually, if I can get this thing to, not too sure how to get this thing to play. I'll actually explain it, it's easier. Each of these is, this is in the days where the way you distributed software was through gold disks. So each of these were the 5 major manufacturers, Compaq, HP, IBM, Sony, Dell. So each of these had a gold disk, which were then given a case and then ceremoniously handed over on the day of the RTM to each of those companies. They then had 2 helicopters. The helicopters took off from our campus. They flew to Boeing Field. There was 5 747s in Boeing Fields. They took off all around the world to each of the manufacturing sites. When this took off, there was TV cameras following these helicopters, as slick as you can imagine. Now, anyone who's released software realizes nothing ever works this way in software. 3 days before this release, now there was no easy way to get software to these manufacturing sites. So this wasn't, we downloaded it through the internet. This was, you had to go through these gold disks. 3 days before it, somebody in the San Francisco office rang up and said, I've got a 2000 Pro laptop. I've just upgraded to XP. My whole user area has disappeared. So this is like, you can't lose data. This is a showstopper. So basically he said, what do you want me to do? And the answer was, well, get you backside to San Francisco Airport, get on a plane, get up to Seattle. He went up to Seattle, and basically the issue was, it was a side issue. He'd moved his user area to a different area. It blew the system, but we couldn't release the product like this. So they then had to, obviously did the patch. They had all the engineers reviewing the patch. They thought they had the fix. They then had to go to testing. They drew lots from the senior management team to who was going to tell marketing that they may have to delay this party. Over the night before this happened, the release happened, they installed it, they built it, they ran all the tests, and all the senior managers came in at 5 o'clock in the morning, and it worked. So, of course, they're sitting there at 5 o'clock in the morning. They've just released an operating system, so they did what any sane person would do, and that's open a bottle of whiskey. By the time this party was on, the reason why the only people on the stage was, that's Jim Olchin, who was the head of Windows, Bill Gates, and Brian Valentine, they were the only salespeople of the whole of the senior management. Most of the others were legless. So the user interface, well, I'm sure you remember this, the Bliss background, the default thing, which isn't bad, considering it's 13 years old. It doesn't look that old-fashioned. The taskbar and the start menu, which will probably be coming back to Windows anytime soon. And of course, Windows up to 2011, was the most dominant operating system in the world. So it held dominance for 10 years. So the features, big focus on internet functionality. Ironically, messaging was another one of those bad software decisions, which was they decided to include it late on, and it was incredibly popular within the business section. And in fact, this is one of the big reasons why XP took off within businesses and replacing the 9X is messaging within the company. Again, it wasn't meant to be that. It just was successful in that space. Networking became easy. I mean, if you ever installed NT4, then especially if it was on alpha and it wasn't that reliable. So the problem was that you'd have to rebuild it every now and again. And then you had to remember which network and things you actually, there's like 4 choices, and you could never quite remember which choice you had, and you had to, you always made the wrong choice and then had to rebuild it again and then made the right choice. And you thought, I must write that down sometime. Well, this was really when networking became trivial. You had, again, a lot of features, and again, this mixture of home to businesses, auto-playing, power management. Faster startup, people got so annoyed at this, where they were complaining about the fact is that when Windows starts, it's not really all there, because it's like it starts certain things and it's still starting in the background, and how unfair it was against other operating systems, because everyone does that now. USB 2, clear type. Reliability obviously beats empty. When I was at a meeting in late 2000, and they actually doing stress testing, and they're stress testing Windows XP against the other operating systems, and they had it against 95, 98, 98 SE, and Windows 2000 Pro, and it was pretty stable. And somebody said, well, where's ME? And they sort of said, well, actually, we couldn't keep it up long enough to stress it. Again, this area here around about the error management was driven a lot by the customers, because they'd put so much into, it's so difficult to install a network of systems that really, you had to bring these reliability issues into the product for them to install, for them to use them as clients within the business area. Big media capability, which, again, looks very crude now, but actually then was quite important. And then infrastructural, product activation, which again upset people, but, brought us in a lot of money, so I was happy. System admin tools, so you can manage these things remotely. And then we released it. And the numbers on the first day were just phenomenal. So, I mean, it was, you were looking at, you had queues of people outside the doors. It was just amazing. Of course, when you're actually collecting crash dumps, anyone who knows anything about reliability, then the first 30 days is the least reliable period there was. So the crashes started coming in. And our support model was was very simple. You got all these crash dumps, you figured out the major issues immediately, you fixed the major issues, and you released the patches. So we were getting these patches out about once a week. Brilliant. Actually, it was a disaster. Home customers actually took a very strange attitude to this because they'd never used to getting seen patches because you wouldn't get a patch. You may get a service pack CD, but you'd have to pay for it. So suddenly they were getting a load of patches, and the only reason you get a load of patches is because it's poor reliability. That's by default. So we were actually, people were saying, well, actually we thought it was good reliability, but actually it must be bad because you're patching it so often. Business customers were just tearing their hair out because for them to, they're going to have to distribute this patch to 10,000 machines. So they can't just distribute it. They have to actually test it out to see if it messes up any of their systems. So it takes them a month. So it takes them a month to test a patch, and we're releasing a patch every week. Well, there's a bit of a mismatch between the two. So the support model has evolved. And XP was the one that drives this. So the way it works now is we have 3 support branches for every product. What's called an LDR, GDR, and service. So an LDR is a general release branch, local general development release, local development service. So this is your security fixes that you get on a monthly basis. The LDR is corporate customers who pay for service. And quite often their patches is because a particular machine doesn't work, and it could be a specific driver issue. And those will be released just to those customers. And then the service branch, in general, has only reliability fixes. And so these security fixes will come in here, and then some of these will come in here. So the principles we have is minimize patch for corporate customers. Again, this has evolved over time in the sense is that if you find a patch for a Hewlett Packard X machine, then you only install that patch on those specific machines. You don't install them on any other machines because the customers, they hate patches, so therefore they want to just minimize the number of patches. And that makes it difficult. So you have if a patch is dependent upon another patch, you then have a dependency trees on patches. So it's quite a sophisticated patching mechanism for there. We release these patches monthly. The way that works is that we develop the patches, we verify the patches, we then work with the security software people to ensure they're synced with us. We deliver the patches. We also have a method of if you get a patch crash that we know about, then we'll actually send you details to basically say, go here. This is now going into the notification center. And we minimize the feature changes in the service branch. And that's basically because if you install a service branch pack 1, you want it to work on everything that you've currently got working. And if that didn't happen, people wouldn't install service packs, and that would then mean there's reliability issues going forward. So then we come into this sort of big area, which is Windows security. Again, a lot of history's been rewritten, a lot of these things. Windows XP was bad from the start. Well, it actually wasn't. Initially, people were upset with the idea that you had to log on with a password. So people thought that the security access was over the top for Windows XP. And then issues started occurring gradually. The problem was the security and reliability are very similar, except that there's one major difference. Reliability is related to the usage of the machine, whereas security is related to whether somebody attacks you. You can have as many vulnerabilities as you want. If nobody attacks you, you're not going to find them. And it's also related to the attack surface that you actually have. An operating system has the biggest attack surface. So because security issues started occurring, because it had such an attack surface, and because there were so many customers on it, then But we were reacting in a very reactive way. So basically, you create a patch, you'd release the patch, and users had a method of downloading the patch. Everything was fine. Reality was that after we release a patch, so we would release a patch because somebody told us, or maybe we already knew we think there's a problem. But it wasn't out in the field. But as soon as we release the patch, then people deconstruct our patches. And we do an awful lot of money to make it more complex. And we basically, I think, we get them down to, it takes about a week or 2 weeks for them to do it now. But they decompose it and figure out, okay, that's what the security hole is. So then they write the vectors. So basically, our patches are the sort of blue-green light for attack vectors. The only people who installed patches were sort of computer geeks who actually didn't need to install patches in the first place. The people who did need to install patches, well, they didn't, this idea of a pull idea didn't work. And the antivirus companies would then rush to get new rules out. Well, of course, if you think of where an antivirus software works on your system, the idea that them rushing to get new rules out meant that quite often they resulted in virus attacks on machines because their software would crash more machines than the virus would have crashed in the first place. So it was, one could say, collectively a problem. And of course, from a reputational perspective, it was very bad. And the reputation was spreading into our server. So basically, because client was bad, then server was bad. So there was what's called a reset. It was about 2003, 2004. And it was really focused initially on engineering education. But in reality, our engineers, we're not exactly bad engineers in Microsoft. There's a lot of things about, people say Unix was designed to be reliable in security from day one. I mean, I'm sorry, it wasn't. It was a big hack. It's the famous thing about Doris Day. I knew her before she became a virgin. It's the same idea with this. Is that really security is not an area. It's a constraint on you, and it's very difficult when you have a complex product to think about security. There was another move which actually we pushed patches rather than actually pulled them. When we did this, it was very contagious. I mean, I read like Slashdot, and people were basically having all these conspiracy theories of what we're doing on the machines. And it's quite funny when you actually attend the meeting where the decision was made. The decision was made basically, nobody's pulling patches. We have to push the patches. Yep, that's the right idea. We'll push the patches. I then read these monologues of this conspiracy theory that we had in this machine, in these meetings about how we were going to undermine things and we can get things onto machines. Now everyone does the same thing. There's still a lot of arguments about you push the patches onto the machine, and whether you then the way we work at the moment is we install them. Depends. In a company you can set your own policies, but for the home user, you nag them or you do it on reboot. Some people now auto patch, which is dangerous. Because you may patch it when people don't want it to happen. We have this thing called the security development life cycle, which really started looking and realizing that that's too limited. It's very difficult to understand your attack surface when you're embedded in an operating system. And so we have a specialized group of security. So it's this idea that individual engineers, depending on that, is just dangerous. Not because of bad engineers, but simply because they have to know the impact on the system of a small change in code. And when your system is hundreds of millions of lines of code, it's very difficult to know that. The problem happens to be is if you apply too many processes in security, then you constrain innovation. So security is this. In fact, most of these things are if you have too much processes, your product's going to die because it's never going to go anywhere. If you have too little processors, your product's going to die because it's chaos. So it's sort of somewhere in between. You have to have the two. One of the things that there was a push for is something like a high-level language, the CLR, to be placed into the whole thing. But it rapidly became true that high-level languages will solve certain issues, but not all the issues. Simply, okay, it stops you having buffer overflows and some of the memory attacks, but it's too simplistic. It's a much more complex issue. And you have this perennial conflict between usability and security. You simply, and there is big rows between the security group and the usability group, because the security group, they're paranoid. That's what we pay them to be. And therefore, they keep asking, okay, you have to keep asking permission to do something like this, and people are not going to do that. The other thing that I think is true is people view this as a Microsoft problem. And if I gave this probably about 10 years ago, then people would say, well, it was a Microsoft problem. Nobody else has this issue. Nobody else has been attacked. Once the OS became more secure, then all the attack people did was just move the attack vectors onto the things. Again, service companies, it's a lot easier because your surface area you can attack is very small. But you can look at any company. You can look at Adobe has got a load of issues. You get Google with Android in the field. It's got a smaller attack surface. But again, an actual fact is if you look at a lot of engineering, not just computer sciences, there's always a great thinking that you can just blame individuals. And whereas an actual fact is that it took us long enough to realize that it's the process that wasn't working. And unfortunately, I think a lot of companies still think that when they have problems, it's individual engineering issues and not underlying process issues. So, my perspective on Windows XP. The goals were too ambitious. I think it was really this idea that trying to handle multiple users, multiple customer bases. People didn't understand the issues they had. I think the way, even though we release things in parallel, you have two teams, server and client. And the server team basically frees the code far before the client team, so especially around the kernel, simply because of this, because they have two different types of customers. And also the scaling of development practices. And this is the area I'm in at the moment, is looking at development practices. And it is this idea, what probably happened in Microsoft was that we went too far towards process control. And we're now trying to sort of find a happy medium between a heavy process and a fast process. And it's a very difficult thing to find. But basically, the big thing taking you can is a development practice that you have may work today, but don't assume it's going to work for the next release of your product. Windows XP was groundbreaking. It was the first home operating system based on an enterprise class operating system. I mean, Mac OS X obviously is now the second one, but this was the first one where you actually have people playing on games using proper, using a proper operating system. You're talking over 1 billion users of the whole thing. It handles, last time I looked, it was 50,000 kernel devices, about 4 versions per kernel device, and over 1 million USB drivers. And USB is a nightmare group to work in because you release a new USB engine and then you have all these failures of USB things not written correctly, and because of backward compatibility, so you end up having to skim all these drivers, and it's a soul-destroying job. It dominated for 10 years. I mean, which is stunning if you think about this day, and there's still tens of millions of people running it. So obviously there's a big difference between the people who pay for it and the people who use it. That's different things. And it's this thing that I think is that how it came about and how it maintained its dominance is you know, there's an awful lot of successes that people can have problems. And unfortunately, I think as general software industry doesn't learn from the past. We just keep making exactly the same mistakes over and over again. But basically, it was a tremendous success, even though it's quite funny that the Computer Society is asking this, because when it was come out, there was a lot of looking down the noses from the computer science section of saying, you know, this is just a load of rubbish, but it's outlived a lot of those things. So thank you very much, and questions? Okay.
So what sort of issues have come out from XP that you've carried on to more recent products?
I think the scaling issue. I think the XP, because of this, you know, in the sense is by developing XP, we went from this sort of engineering based culture. So if you think of Agile, then it was on a bigger Agile thing. Because of the issues of XP and then the security and then Vista, that actually caused us probably to go much more, to rely too much on process. So that some of the good things, things like getting the messenger in at the last minute in the product, then you'd never do that in sort of Windows 7 or Windows 8. But the answer is probably we should be doing that. So there's things which we need to figure out, and a lot of it is to do with the quality is not instead of having quality as a single entity, the quality of the memory management system has to be very high. The quality of Solitaire doesn't. So you don't need this sort of single process to do things. So I think that one. I think some of the things we forget about is, again, this idea of development practices of, some people in Microsoft and a lot of companies always think this way will solve anything known to man. And of course, it's most engineers will realize it's a mixture of ways of doing things. So, I think we still make mistakes from XP.
What will be the innovation for Windows 9?
I think one of the things, I mean, this is one of these empty. Yeah. Windows 8, there's certain issues with Windows 8, which actually, one of the things that actually Windows XP started and then became very popular was the idea of beta releases. Now, for whatever reason, the person running Windows 8 became like believing in this idea of Apple, where you can actually just release something. I think, again, it's like anything else. That method worked for a while. It probably won't work for Apple. It certainly didn't work for Windows 8. And I think as if they would have released Windows 8, they would have realized that there were small things, very simple things would have made it a lot easier, which are things like, not going to the desktop if you prefer the desktop, and the start button. And those things were taken out. So it wasn't even a case of us not doing things. It was actually extracting things. So I think, and they would have been found by the user thing. But the Windows 8, what it's trying to do, and what it has done, is to go back to exactly the Windows 2000, which is a unified operating system, which is between the phone, the client, the server, the Xbox. And so what we now have is and this is where you then have Visual Studio, various other things, the ability that you can write one piece of software which will then be deployed on all the other things. And so for everyone, and where it did wrong was basically say, right, well, because we're not good on the tablet, we'll solve the tablet problem, forgetting the fact that you still had to keep the other people happy. But I think is that by, fundamentally, the other, Apple and Android and Google will have to do the same thing.
Compatibility, I think, is one of the huge issues.
Yeah, yeah.
It says, I want to use my iPad, I want to use my desktop, I want to use my work machine, and I don't want to know which one I'm on.
Yeah, and I think it's that's but when you do these architectural steps, it's a pain. It usually has to be driven in a sort of dictatorial way, and then you're very dependent upon whether it's a good dictator or a bad dictator. And I think is that so he did good things. Sinofsky did good things, but I think is that if he would have not been obsessively secret, if he would have released it, because the internal people were saying, we don't want to go to the, if it's, I haven't got a touchscreen computer, I don't want a touchscreen interface. Give me the desktop. And also, the start button is, even though you can just type the thing in and you have it, it's, people, that's the thing that really put most people off. So, yeah. And I think it's and it's those two. You want to, Office, I think, were the most successful by going to the ribbon. And that took people a while, but that was very clever because they did it by, so basically when you say you want to be part of a, will you help our usability service, then what we do is we monitor usually about 5 million people continually. And these are usually, most of them, new installs. And what happens is that you monitor in the background every event. It depends on which event you wanted. So within Word and Office, what they did was they monitored how people, what was the most common usage in the drop-down menus. And when they released the ribbon, they actually then monitored how people struggled to find in the ribbon. So they actually adopted the ribbon very well. So I think that was a very successful move from people. Some Office experts hated the ribbon because it stopped them being experts. It sort of made other people, you didn't have to ask somebody where was this feature, people could find it. But it was a successful transition, and I think is that it's very difficult to do a successful transition from one to the other. It could have been done better. And I think is that the going forward with Microsoft is this unification across devices. I think that's it. Is it? Well, thank you.
Thank you very much indeed.